Can you hear me? Good afternoon.
Yes, madam.
Yes, madam. Good afternoon.
Okay, sorry for the delay. So actually it's difficult to start at time since we are also at home, and when kids are around it's very difficult, right? So sorry again. And okay, yes. So there are some announcements to be made. So this Thursday, 9th of December, you will have the first quiz, right? So don't be afraid, it's just a simple quiz. Yes, at 10:30, right? From 10:30 a.m. onwards, it will going to be conducted. So some of you have asked me that they have some problems in participating the quizzes. So it's okay, but there should be a valid, proper reason not to participate, right? So for those people who do not attend to the quiz, I will give you another day, right? But you have to inform me before this Thursday with a valid or proper reason with the proof, right? So someone has their sister's wedding. එහෙම දේවල් වෙන්න පුළුවන් නේද? එතකොට සිස්ටර්ගේ වෙඩින් එකට යන එකට වඩා ක්විස් එක ලොකු වෙන්න විදිහක් කොහෙත්ම නැහැනේ. පෞද්ගලික දේවල් ඉතින් හැම වෙලේම නම්බර් 1 වෙන්න ඕනේ. ප්‍රයොරිටි එක දෙන්න පුළුවන් වෙන්න ඕනේ. ඉගෙන ගන්නත් ඕනේ. නමුත් ඒ වගේ දෙයකදී ඉතින් අපිට සාධාරණව බලන්න පුළුවන්නේ. එක්ක අසනීපයක් වෙන්න පුළුවන්. පවුල කෙනෙක්ගේ නේද? ක්විස් එකට එන්න බැරි හේතුවක් තියෙනවා නම් විතරක් මේ කියන්න. හැබැයි මට ඉන්ෆෝම් කරන්න ඕනේ ක්විස් එක තියෙන දවසට කලින්. ඊට පස්සේ ඉන්ෆෝම් කරාට වැඩක් නැහැ නේද? වැලිඩ් රීසන් එකක් තියෙනවා නම් ඊට කලින් ඉන්ෆෝම් කරන්න පුළුවන් වෙන්න ඕනනේ. So before the quiz you have to inform if you are unable to participate to the quiz. So those are the things I wanted to announce, right? Any method you can use, either WhatsApp or email, right? So I think it's easy if you can send me WhatsApp message rather than sending an email. So send me through WhatsApp, but only for valid reasons, right? I'll give the permission only for the valid and valid reasons with the proof, right? Okay. Right. Then I have uploaded the answers to the problem sheet number 2 to the LMS, and there is a small correction to be made. Yes. Can you see this 5th problem in the problem sheet number 2? Right here, as an experiment, a temporary roundabout is installed the crossroads. The time x minutes which vehicles have to wait before entering the roundabout has probability density function. The density function is given, and here the limits. Actually in the problem sheet it is given as 0 to 10, right? So it should be corrected as 0 to 2.5. So I'll tell the reason why I have to change that bound. When we are finding the mean, I guess you have a negative madam. So are there any students who started the course today onwards?
Yes, madam.
Okay. So what I have to say for those students is, those students are, so first go through the LMS, right? I have uploaded all the materials, and you have to obtain help from others as well, right? Since we are almost past 4 weeks, right? So therefore, get help of others and go through your notes, go through the tutorials. So this week also you have to submit a tutorial. So get help of others. If you have any question, any doubts in your subject related matters, you can contact me. In the first note, I have my all the contacts, my email, WhatsApp number, all the things. So you can contact me. So I think you have to work hard, because there are some things to cover up by yourself, since we have almost done 4 weeks, right? So be concentrating the lectures as well. If you have any doubts, you can personally contact me after the lectures, right? Okay. So the problem sheet 5.
Okay, thank you, madam.
Okay, problem sheet 2, 5. Here I have to change the limits, because I think when finding the expected value or the mean, you got minus values, right? Is that so?
Yes, ma'am.
Oh, yeah. So it's okay to get minus values as an expected value or mean. It can happen, right? So if we considering a random variable which measures a temperature like things, right? So temperature can take minus values, and they have a meaningful values when it becomes minus or negative value. But according to this problem, as an experiment, the X variable is the time, right? It's time. So it can't get negative values. That's why there is a problem in limits here. So I have had to change the limits. So please change the limits to 0 to 2.5. Okay. So we have to find the mean. Mean is the expected value. So we have to integrate it for all x fx dx. And then you have to substitute the limits, the given limits, 0 to 2.5, and then obtain the integrals. So the mean value should be 0.833, right? And you can find the standard deviation by calculating the variance. So the equation for the variance is this: EX squared minus the whole thing squared of expected value of X, right? Then you can obtain the expected value of X squared using again the integrals x squared fx dx. Just substitute the function given, the density function, and after the integrating, substitute the given limits, and then you can find the variance of X, and the square root of the variance is the standard deviation. So check your answers with these given answers by me, and if there are any correction, please tell me, right? Okay. So go through the answers, and if there is any question, you can contact me, right? Okay. Okay, now we have already completed 2 chapters. The first one is just an introduction. What is a probability, right? The basic theorems we are using in probability. The addition rule, multiplication rule, Bayes theorem, total probability law, and permutations, combinations, those things, right? And in chapter 2, we learn about random variables, right? Random variables. Under random variables, there are 2 types of random variables, discrete and continuous, right? So according to the way we are collecting data, if the data are continuous, then it is a continuous random variable. And if the data are discrete, then it is considered as a discrete random variable, right? So each and every outcome in a random variable has a probability, right? So those probabilities are called as probability distributions. Okay, so we build up some probability distributions there, and using those probability distribution, we calculate the cumulative distribution. The probability distribution in continuous case, we call it as a probability density function. So using the probability density function, we learn how to obtain mean or the expected values. And then we learned about the moments. Moment about the origin and moment about the mean. Right? That is the deviation from the either origin or deviation from the mean. If we take 0 as the origin, so it is considered as the deviation from the origin. So its moments are about the origin. If we consider the origin as mu or the mean, it's the moment about the mean. So there are 2 types. So first moment about the origin is called as mu or the mean. And then the second moment about the mean is called as variance, right? Likewise, we learned how moments are calculated. Moments are the just expected value of the random variable, the power, right? Expected value of XR is the rth moment. In other words, right? So after that, we learn how to obtain moment generating function. So the moment generating function is the just expected value of e to the power tx. So using that, we can obtain the moment generating function, and using the moment generating function, also we can calculate moments. How? So if we obtain the derivative with respect to r, so it's the rth moment of that distribution. Okay, so those are the things we learned in last chapter. So now we are going to learn some special types of distributions that are already identified. So again, we divided it into 2 as discrete and continuous distribution. So first we learn what are the discrete probability distributions, the special distributions, right? If a random variable is a discrete variable, its probability distribution is called a discrete probability distribution. Following are discrete probability distributions. So there are some special distributions in discrete probability distributions. They are discrete uniform, Bernoulli, binomial, geometric, negative binomial, and Poisson. So you are going to learn these distributions, and for which kind of incidence we are using those probability distributions as well, right? So each and every discrete probability distribution has a function. So since it has a function, we can obtain the mean values, the properties, right? Just the properties: mean, mean or expected value, variance, then moment generating function. So those are the special characteristics of a distribution: mean, variance, and especially the moment generating function. So under this chapter 3, we are learning discrete probability, special discrete probability distributions and their properties. Okay, so the first one is discrete uniform distribution. So there are two types of uniform distributions actually. When it comes to continuous case, it has a continuous uniform distribution as well. So here we are considering the discrete uniform distribution. Okay. So here is the definition of discrete uniform distributions. A random variable has a discrete uniform distribution, and it is referred to as a discrete uniform random variable if and only if its probability distribution is given by the probability x equal x is 1 over n, for x goes to 1 to n. Right? So this is the discrete uniform distribution. So according to the equation, it is clear that each and every outcome has a same probability to happen. 1 over n means same probability, right? If you roll a die, then the value obtained in the phase has every value from 1 to 6 have the same probability of obtaining. So it's an example for discrete uniform distribution. So each and every outcome has a same probability to occur. So this type of distributions are called uniform distributions, and their distribution, probability distribution, is given by this equation, right? So I think it's clear what is a discrete uniform distribution. So these types of distributions are called discrete uniform distribution. So now we are going to learn about the properties of these discrete uniform distributions. What are the properties? Main properties we are considering here: mean, variance, and the moment generating function. So now you know how to obtain the mean. So mean of x is the mu, just the expected value of x. So since this is a discrete one, we use the summation. Summation from x goes to 1 to n, x into fx. Fx is here 1 over n. So find the mean first. Try to obtain the mean. Okay, did you find it? It's very easy, right? So we can take 1 over n out. Then it is summation of just the x. That means 1 plus 2 plus 3 up to n. Right? So from the A-level knowledge of series, you know that you can write this as 1 over n n into 1 plus n divided by 2. So n and n cancels out. 1 n plus 1 over 2. So this is the mean of the discrete uniform distribution. මේ distributions ඔයගොල්ලෝ මතක තියාගන්න ඕනේ. mean variance moment generating function එක නම් generate කරන හැටි දැනගන්නත් ඕනේ. ගන්න හැටි දැනගන්නත් ඕනේ. මෙන්න මේක මේ function එක මතක තියෙන්න ඕනේ. Okay, now find the variance. So to obtain the variance, you need expected value of x squared minus expected value of x, the whole thing squared, right? So we can substitute the value of mu here. Just find expected value of x squared. we can take 1 over n out and just the summation of x squared. It is 1 squared plus 2 squared up to n squared. Again, using the knowledge of series, right? Series I think it's in not A level, O level, I guess, right? So we can write this 1 over 6 n into n plus 1 and 2n plus 1. So this is n plus 1, 2n plus 1 over 6. And using this, you can find the variance. It is just expected value of x squared minus the whole thing expected value of x squared. So just substitute values. N plus 1, 2n plus 1 over 6 minus n plus 1 over 2 By simplifying this, you will get n squared over 12. Did you get that answer? Okay. Okay, then the moment generating function. So someone has asked me to explain it again. So it's just simple thing, right? So when we want to obtain the variance, just obtain x squared minus expected value of x, the whole thing squared. Then if we find x squared, it's just the summation of x squared into 1 over n, the x into fx, right? So 1 over n, 1 squared plus 2 squared plus 3 squared up to n squared. Then this series, the summation of this series can be written as 1 over 6 n plus 1, 2n plus 1. Go through your level note, series note first, right? Then you will understand. Here I can't do all the things again and again, because you have gone through A levels now. So it's n plus 1 into 2n plus 1 over 6. Then by substituting this one to this, you can obtain variance of x. N plus 1, 2n plus 1 minus the expected value of x is n plus 1 over 2. So the whole thing squared. So just simplify. Expand these two and then simplify. So you will obtain n squared minus 1 over 2. It's simple mathematics. Okay. Now the moment generating function. So we know that the moment generating function is just the expected value of e to the power tx. Okay. So its summation of x goes from 1 to n, capital N, e to the power tx into 1 over n. So this is, we can take 1 over n out, and e to the power tx, x is from 1 to n. If we substitute 1 in place of x, it is et plus 2 e to the power 2t. Likewise, if we substitute the final value n, it is e to the power nt. Then we can take 1 over n out. And again, from the knowledge of series, here, if a series is Sn, if it is 1 plus r squared up to Rn minus 1, the summation is given by 1 minus r to the power n over 1 minus r, right? So we can take 1 et out And we can write this one as 1 plus e to the power t up to e to the power n minus 1 t. So now we can use the summation of that series, right? The concept we used here. So how can we write it? 1 over n is like this, and et, and the summation of this series can be written as 1 minus, in place of r we have et, right? So et into n, 1 minus e to the power t. So this is the moment generating function. So using this moment generating function, we can find any moment. How? Just obtain the derivative. Right? If you want to find the rth moment, so just apply mrxt here and drt over dtr and set t equals 0. Then you will obtain the rth moment. If we obtain derivative once, it's the first moment. And twice, it's the second moment. Likewise, we can obtain the moments using the moment generating function by just using derivatives, not the integration. To find the moments in regular way, you need the integration. But using the moment generating function, you can just easily use the derivatives. So you can just find the new by setting t equals 0. Okay. Okay, consider this example. The number obtained by rolling an ordinary 6-sided die. So it is an example of discrete uniform distribution. Right? Why? You know that probability of x equal 1, it is 1 over 6. Probability of x equals 2, it's also 1 over 6. So x equals 6, again it is equals to 1 over 6. Right? So each and every outcome has a same probability value. So we can then denote it by a discrete uniform distribution. n is equals to 6 here. Right? So we can denote it by this notation. Capital X, the random variable capital X, follows a discrete uniform distribution with the probability 6. So the number of outcomes, the n is denoted here, 6. So the number obtained by rolling an ordinary 6-sided die has a discrete uniform distribution. So if someone is saying about a rolling die experiment, we know that that experiment has a discrete uniform distribution. Right? Okay, then the second one. The discrete variable x is such that probability x equal x is C for 20, 30, 45, and 50. Right? So C means the probability is same. Right? So you're asking to find probability distribution of x, expectation of x, probability of x less than mu, and the standard deviation. Okay, try to obtain the probability distribution of x. So we know that since all the outcomes has same probability value, and also the probability sum up to 1. So using that concept, we can find the value of C, the probability. So once we know the probability C, we can find the probability distribution. Okay, try to do that. So there are 4 values, 20, 30, 45 and 50. So those 4 values, each of which is equally likely to occur. Right? So probability x equal any x value is 1 over 4, that is 0.25. For r equals 1, 2, 3 and 4. 1, 2, 3, 4 means here 20, 30, 45 and 50. So this distribution is a discrete uniform distribution. Right? We can write it as x is a discrete uniform distribution with 4 observations. Then the expectation of x, expected value, mu. It is the expected value of x, summation of all x Okay, then the probability of x less than mu So now we have found mu as 36.25. So what are the values? Less than mu value, it is 20 and 30. Right? There are only two values. Then you have to calculate the standard deviation. For that, you need x squared so all the probability values we know that is 0.25. We can get it out and then square the x values 20, 30, 45 and 50. Then using above information, we can find the variance. It's just x squared minus the whole thing squared. Just substitute the values. Then the standard deviation is the square root of this thing, the variance is somewhere around 11.9. Is it clear? Any questions? Okay, that is the discrete uniform distribution, right? When each outcome has the same probability to happen, then it is considered as a discrete uniform distribution if the random variable is a discrete one, right? So the next distribution is Bernoulli distribution. Bernoulli distribution. A random experiment that has only two outcomes is called a Bernoulli experiment. Named after Jacob Bernoulli, we arbitrarily call one outcome a success. We denote it by x equals 1 and the other a failure denoted x equals 0. So in the Bernoulli distribution, there are only two outcomes, right? There are only two outcomes. So when we roll a die, there is more than two outcomes, right? There are 6 outcomes. But in a Bernoulli distribution, you will have only two outcomes. If we arbitrarily call one outcome a success, other one definitely be a failure. අපි අභිමතයේ පරිදි arbitrary අභිමතයේ පරිදි අපිට එක outcome එකක් success එකක් විදිහට choose කරන්න පුළුවන්. So we arbitrarily select one outcome as a success and the other one automatically becomes the failure. So it denotes by the 0, x equals 0, x equals 1. It is the success. When x equals 0, it is the failure. For an example, when we toss a fair coin, we know that there are only two outcomes, right? And if we take obtaining head as the success, then definitely the obtaining tail will be the failure. So if we obtain head, we can assign it as x equals 1, and tail, we can assign x equals 0. So we arbitrarily call one outcome as a success and other one is automatically becomes the failure since there is only two outcomes. Another example, sex of a newborn baby. It could be either male or female. Again, two outcomes. Two outcomes. That should be highlighted. Two outcomes. In a Bernoulli distribution, there is only two outcomes. So here male and female. If we take having a male as a success, then if we have a male, it is considered as a success, x equals 1. If we have a female, x is 0. If we consider having a female newborn baby as a success, then the having male automatically becomes as the failure, right? So thus the probability distribution of x is probability x equals 1 becomes p. P is here the success, probability of success. Then what is the probability of failure? So we know that the total probability is 1, right? So since there is only two outcomes, if one outcome, if the probability of one outcome becomes p, then definitely the other outcome is 1 minus p. And here in the Bernoulli distribution, we denote it as q. Q is equals to 1 minus p. So p is the probability of success, right? So in summary, Bernoulli distribution is a distribution having only two outcomes. One is arbitrarily called as a success, and then other one is going to be a failure. The probability of success is denoted by P, and then probability of failure is denoted as Q, that is 1 minus P. Okay. So the definition, a random variable x has a Bernoulli distribution and it is referred to as a Bernoulli random variable if and only if its probability distribution is given by. So in a discrete uniform distribution, we know that we can write the distribution as 1 over n, right? Probability of x equals x can be written as 1 over n. So like that, here the distribution is given by this function. Probability of x equals p to the power x into the 1 minus p to the power 1 minus x. So here 1 minus p is the q, the probability of failure. In other words, in other notation, we can write it as just Px Q 1 minus X. So we know that Q is equals to 1 minus P. Here we have only two outcomes, 0 and 1. So here P is the probability of success, and the probability of success should be in between the range 0 and 1. And we denote the Bernoulli distribution in this notation. X, the random variable, follows a Bernoulli distribution with probability of success P, simple P. Right? So this is the Bernoulli distribution. Okay. Then consider these examples. Consider the experiment of tossing a fair coin. Let X head equals 1 and X tail equals 0. So here we consider the probability of success is to having head, and having tail is the probability of failure. Right? So, sorry, the random variable X is obtain X equals 1 when it becomes head, and the random variable equals 0 when the outcome is tail, right? It's not the probability, it's just the random variables. Then X is the Bernoulli variable with P equals half. Why? It is a fair coin. Since it is a fair coin, it has half or 0.5 probability of obtaining head and 5 probability of obtaining tail. So the probability of success is 0.5 or half. So this is a Bernoulli. Here X follows a Bernoulli distribution with probability of success equals 0.5. Then example 2, probability, consider the sex of newborn baby at a childbirth. So we take random variable X, male baby born. So if it becomes 1 when a newborn baby is a male, and it becomes 0 when the newborn baby is a female. So again here X is a Bernoulli variable with probability P. Right? So here we can't assign any probability value because we don't know the probability, right? From past experiences or either using a survey result, some can obtain a value for P, right? Then the third one, consider bomb hitting a target. So when bomb is hitting a target, it can be on the target or miss the target. Just two outcomes, right? It can be hitting, or it can be missing. So if we take the success as hitting and the missing, the failure is 0. Right? So it is also a Bernoulli variable with probability P. Probability of success P. Right? Then consider drawing marbles at random from a collection of 10 black and 20 white marbles. Let getting a black marble as a success and getting a white marble as a failure. Right? So we take getting black marble as a success. Then what is the probability of obtaining black marble? Altogether there are 30 marbles and obtaining black marbles is 10 over 30. The probability of success here is 1 over 3. And the probability of failure, that is obtaining white marble, it is Q denoted by 1 minus P, it is 2 over 3. Right? So same thing repeating here, just ignore it. So it is a Bernoulli distribution with the probability of success equals 1 over 3. Okay. Then the next example, consider the planting of 5 beet seeds in a row if the probability of germination of a seed is 0.8 and germination of the seed is a success. Then this corresponding to 5 Bernoulli trials with P equals 8. So here 5 beet seeds are planting. So germination of 1 beet seed, if we take the germination as a success, then the probability of success is given as 0.8. Right? Then there are 5 trials. අපි එක beet seed එකක් ගත්තොත් ඒ එක beet seed එකක් germinate වෙන්නත් පුළුවන් නැති වෙන්නත් පුළුවන්. So there are 2 outcomes, either germination or not germination. So if the probability of germination we take as a success and the probability of success is 0.8, then it becomes a Bernoulli distribution with probability of success 0.8. Right? Here there are 5 beet seeds. So the same thing repeated. Right? So these are called trials, Bernoulli trials. Right? Germination 1 beet seed is a Bernoulli distribution and there are 5 seeds. So there are 5 trials. It is called as a trial with the probability of success 0.8. Right? So if we consider the probability of obtaining outcome like this, that means first beet seed has germinated, second not, third yes, fourth no, and fifth yes. So we can obtain the probability using the Bernoulli distribution. So we know that here it is a probability of success. So 0.8. Here probability of a failure. 1 minus 0.8, 0.2. Here again a success. Here failure. Here a success. So this is the probability value. So is this the total probability? No, we can't say this is the total probability. My total probability කියන එක නෙවෙයි. Seeds 3ක් germinate වෙන total probability එක නෙවෙයි. ඒක හොඳට මතක තියාගන්න ඕනේ. අපි ඊළඟ distribution එකට යද්දී මේක උමනා වෙනවා. So this is not the total probability, right? මේ විදිහට නෙවෙයි total probability එක ගන්න තව විදි තියෙනවා නේද? පළවෙනි එක germinate වෙලා, දෙවෙනි එක germinate වෙලා, තුන්වෙනි එක germinate වෙලා, ඉතුරු දෙක germinate නොවි තියෙන්න පුළුවන්. මේ කියන්නේ එක event මේකක් ගැන විතරයි. outcome එකක් ගැන විතරයි, right? කොහොමද ඒ outcome එක ආවේ අපි මේ just considering an example, right? මේ අපි මේක outcome එකක් ගැන විතරයි මෙතන මේ consider කරන්නේ. මේක තව වෙන්න පුළුවන් 1 1 1 0 0 වෙන්න පුළුවන්. එහෙම නැත්නම් 1 0 1 1 0 වෙන්න පුළුවන්. මේ වගේ ගොඩාක් විදි තියෙනවා. අපි ඒක calculate කරන්නේ ඊළඟ distribution එකකින් අපි ඒක කතා කරමු. It's a binomial distribution, right? මේ අපි එක outcome එකක් විතරක් සැලකුවොත් මේ විදිහට ගන්න පුළුවන් Bernoulli distribution එකකින් කියලායි මට කියන්න ඕනේ. Okay? Then the next one, suppose that 20% out of million lottery tickets are winners. If 5 tickets are purchased, a possible outcome could be 0 0 0 1 0. මේ විදිහට වෙන්න පුළුවන්. හැබැයි මේ විදිහට විතරක් නෙවෙයි වෙන්න පුළුවන්, right? මම මේ නිකන් එක outcome එකක් විතරයි මෙතන අරගෙන තියෙන්නේ. Just one outcome. මේ විදිහට වෙන්න පුළුවන්. එහෙම වුණොත් මේකයි probability එක කියලා මිසක් මේ total probability එක නෙවෙයි, right? This is not the total probability. ඊට වඩා ගොඩාක් වෙන්න පුළුවන් විදි තියෙනවා. අපි permutations වලදී ඉගෙනගෙන තියෙනවා permutation combinations වලදී. So this is not the total probability, right? Just an example, for an example, only one outcome is considered. එහෙම එක outcome එකක් දීලා තියෙනවා නම් අපි Bernoulli distribution එක පාවිච්චි කරලා probability එක හොයන්න කොහොමද කියන එකයි මම මේ කියන්න try කරන්නේ, right? So the first one is a failure. Second one is a failure. So since it's 20% means 0.2 is the probability of success. Since therefore probability of failure is 0.8. So this is again a failure. This is a failure. This is a success, and this is a failure. Right? So this is the probability. In fifth example, it should be 4 success outcomes. No, in fifth example, there is only 3 successes, right? Only 3 successes there, not 4. Right? So that is the Bernoulli distribution. Okay, Bernoulli distribution. Okay, then the properties of Bernoulli distribution: mean, variance, and moment generating function. Okay, right. Try to obtain the mean. First, try to obtain the mean. So is that clear? So the mean is just the P, right? It's not capital P, it should be simple P. Okay, is it clear? Just substitute the values 0 and 1. There are only two outcomes, 0 and 1. Right? If we substitute the value of 0, it's 0. 0 into p to the power 0, 1 minus 3 into the power 1. So it becomes 0. If we substitute 1, 1 into p, 1 minus p into 0. So it just p. So it becomes p. Right? Then the variance. So the variance, it is expected value of x minus mu squared. So you can just find what is expected value of x squared and then substitute, or else in place of mu, we can substitute the value p here. So it becomes x minus p. So x minus p squared, the fx. So what is the variance of the Bernoulli distribution? Any answers? Yes, Tarushi, you are correct. Yeah, yeah. Try to obtain this, right? 1 minus p. So the variance of the Bernoulli distribution is p into q, where q is 1 minus p. So it's better if you could recall these equations, right? You should know what is the distribution, what is the function of the distribution, and it's better if you can recall these equations of mean, variance, and the moment generating function. Okay. Then finally, the moment generating function. So it's the summation again from 0 to 1 e to the power tx into px 1 minus p 1 minus x. Try to obtain the moment generating function as well. No. Send me answers. Other answers? Okay, I'll give the answer. Try to obtain that one. Just some simple calculations. So it should be q plus p into e to the power t. Right? Try to obtain this one. So that is the probability, sorry, moment generating function of the Bernoulli distribution. So today we learned two discrete distributions, two types of discrete distributions: discrete uniform distribution and Bernoulli distribution. So in discrete uniform distribution, each outcome has an equal chance to occur, and therefore the distribution is 1 over n. And then we derive the mean, variance, and moment generating function. And the next distribution is Bernoulli distribution. In Bernoulli distribution, there is only two outcomes. We denote it as success or failure. If we denote P as a probability of success, then 1 minus P is the probability of failure. So we denote the probability distribution of Bernoulli distribution as P to the power x into 1 minus P to the power 1 minus x. And then we derive the mean, variance, and the moment generating function of the Bernoulli distribution. Right? So next day, mean it should be next week, right? So this Wednesday you have the tutorial class, and Thursday you will have the quiz. So those who can't participate to the quiz on a valid reason, you have to inform me before the quiz. Then I'll give a made up quiz for you, right? The quizzes වලට බය වෙන්න එපා. quizzes දෙන්නේ ඔයගොල්ලෝන්ගේම හොඳට. මොකද එතකොට ඔයගොල්ලෝ අර හැම වෙලේම subject එකේ ඉන්න ඕන නිසා සහ ඔයගොල්ලන්ට අන්තිමටම continuous assessment වලට මේකෙන් mark ටිකක් එනවා. කාට හරි බැරි වෙලාවත් end එක හරියට කරගන්න බැරි වුණොත් මේ continuous marks කොච්චර වටිනවද කියලා තේරෙනවා ඒ වෙලාවට. Right? No, this part is not included to the quiz. The quiz comes only for the quiz. Chapter 1 and chapter 2 only. The quiz 1 is based on chapter 1 and chapter 2, right? Chapter 3 and 4, we will give another quiz. So today's part is not included in the quiz. බය වෙන්න එපා, just a simple quiz නිකන් පාඩම් කරන්න. ඒක ලොකුට ඔළුවට ගන්න දෙයක් නෙවෙයි. Right? Okay. Any questions regarding today's lecture session or regarding the quiz? Okay, I hope no any questions then. So let's meet again, and thank you for participating.
Thank you, madam.
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 Thank you, madam.